All right. Next up, we have the one and only Stefan Edwards.
Thank God there's only one of me. I don't know how the world would survive if there were if there were multiple of me.
I'm not sure how the world survives with one of
you. Worlds colliding.
Yes, very, very much so.
Brian Green's on that note too.
Brian jumped in.
Having worked with you for what, close to a decade now? One and only is good.
All right, I'm going to put your talk up here, Mr. Loji.
Yep. Yeah, we're going to let you go to town. I've got Google fired up, so we'll see where it goes, right? At least this one's Wayward InfoSec Youth, so it feels appropriate.
This isn't modeling kilts or anything, is it?
No, this is about some of the things that Brian actually on the latest threat model that you and I have worked through, some of the more like dynamic modeling things. I took some of the ideas that we've had for a while, and I said, you know what, I want to sit down and distill them into a talk. I'm going to speed run a talk. I don't care how much of a rant it becomes, but I wanted to throw together some code. I wanted to throw together some ideas on how we can move towards more dynamic modeling of things compared to the way that we've done a lot of these sorts of things, which is like fairly dead and sort of static in a lot of ways. Yeah. No, Rich, it's not that bad. I promise I won't use any thesaurus or SAT word. But yeah, no, that's perfect. So good evening, everyone. Thank you very much. This is obviously my meditation on applying various InfoSec models to your programs, to your tooling, how I explore this space, and really trying to give your best blue steel as you go through and model things. We'll talk about the sorts of modeling that I'm interested in, the sorts of things that I do for the work that I do. It's not exactly the same sorts of models that everyone does. It's also slightly focused on the sorts of work that I do. We'll get into that. But there's quite a bit in here. And I really wanted to start this talk with the takeaways, not so that you can run away, although obviously it does give you that opportunity here. But I wanted to start with the takeaways so that you can really have an upfront view as we go through this entire talk of what I'm trying to give. Normally I have takeaways right after the intros and all that sort of jazz. But this talk, I wanted it in your face. And I wanted you to really think about this the entire time. There are really 4 domains that we can model and we probably should be modeling. Risk is the obvious one. And then progressing down the commonality scale here, we have threat, maturity, and then sort of semi-formal modeling. And I'll talk through what that actually means insofar as what I'm talking about here tonight. And I want to do it in a way that Brian and I run our threat models, which is to say data-centered, control-centered, really asking teams to walk through the connections, walk through what's actually released, what's actually impacted by these sorts of things, with a focus on practical techniques. A lot of the interesting things that we can do, a lot of the fun things that you'll read in papers, they're not necessarily the most practical areas that you can head towards. They're usually techniques that you can apply for a very specific domain. And I really wanted to go through and show how I've wrestled with some of these sorts of things for certain client projects, and also to make reference to other people that I know are working in the space and doing fairly interesting things. And if there's any spicy takeaway from this, I do think that we need to stop being afraid of domain-specific languages, and I think we need to stop being afraid of actually modeling things. Very often in InfoSec, we have a tendency to come up with Excel sheets, come up with CSVs, come up with diagrams, those sorts of things. And then we sort of produce these outputs, we produce these accoutrements, and then we literally do nothing further with them. How many folks have seen architecture diagrams? How many folks have seen risk registers, whatever, that are out of date, that don't match what their actual program is doing, that don't match the way that developers think, that sort of thing. And obviously, I'm a former Lisper. I'm not afraid of DSLs because every single Lisp program that you open is in itself its own DSL. But I do think that we need to start looking at APIs and looking at DSLs and understanding our models from that perspective, and start actually looking at our systems from the ground up. And I'll go through what I mean by all of this. If there was an ad for this, and what's sad is I actually took this advert from a school for wayward youth, but if there was an ad for this, it would really be this. If you have the inability to understand your InfoSec programs, if you're anxious about the state of your systems, if you're feeling despair and loss and those sorts of things as to where your data ends up, this talk is an attempt at showing a way forward and how I have overcome some of these problems myself, and the way that other folks who are working in this space do so as well. Obviously, there's quite a bit that I'll be going into. We start with takeaways, go through all those sorts of things. I want to talk about what actually is modeling. I think that is slightly different than what most folks will understand per se if they think about like maturity models or they think about threat models. The way that I tackle these sorts of things are ever so slightly different. I wanted to talk about why we model, what we model, like some practical techniques, then get into the different areas that I'll be talking about, talk about what we get out of modeling, talk about some other areas, and then jump right into the last bit into how do we actually apply these sorts of things. Who am I? If you've seen Absolute AppSec, you've heard me rant and rave before, but my name is Stefan Edwards. I am a practice lead at Trail of Bits. I go by a Twitter handle and everything handle of Lojikil. I basically work in defense, fintech, IoT, all sorts of stuff. My main areas of focus at Trail of Bits are threat modeling, vCISO, some programming language theory work. I work with symbolic execution quite a bit, work with static analysis. I also provide the sort of like InfoSec thuggery to Trail of Bits. Trail of Bits has quite a bit of academic background, and then a number of folks who have joined in the last 3 years bring the sort of like on the ground background in policy, those sorts of things. And that's my main influence at Trail of Bits itself. And who is Trail of Bits? We are we're basically a boutique InfoSec consultancy. We do quite a bit of work. I think the interesting thing, obviously, Evan is a huge advertisement to what we do, but the sort of work that I'll be focusing on are the sorts of things that are probably more interesting this evening are the sort of fundamental cybersecurity research programs that we do for places like DARPA. Some of the projects that we have, some of the work that we do comes directly out of DARPA funding, or it's DARPA adjacent, and we work very hard to make sure that those actually are usable by the community or usable by the larger InfoSec field, and that's the focus that we'll be talking on tonight. If you're interested in any of our publications, and I'll reference some of them as I go through tonight, there is what we can publish on our publications index here on GitHub. This talk actually uses a programming language that I wrote. It's called Caramel. It is a combination of a few different ML programming languages that I've worked in, a scheme dialect that I've worked in called Digamma, some existential sadness. So you'll see some things there. If you want to grab Caramel, there's a GitHub link in here. But we'll basically be covering 4 different forms within Caramel itself. We'll use type, which introduces like variants or tagged unions. So if you've worked in C before, or you've worked in Scala, and you've seen case classes in Scala, or a struct with a union within it within C, that's the sort of form that we're talking about there. We'll talk about constructors that come off of type. We'll talk about records, which are similar to structs or classes in other languages, and we'll talk about function definitions. And the focus of this talk was not to do things that would be super academic, super different. I really wanted to show that there are very simple tactical things that you can do in any language. I'm using Caramel because why not? It's my talk, and I'll do what I want to. But you really can apply any of these things to any language that you're working in here. And the point is that we need data ingestion, and we need some sort of framework that you can work in. You can start to think in the languages, and you can start to think with the models that you've produced for your program. Nothing in here is going to be generic that you can just walk away with and start to apply right away, right? The whole point is that we should be writing models, and we should be making DSLs for our own use. And so I stole my own language for that. So what do I mean by modeling, right? When I'm talking about modeling, I'm really talking about this. Like modeling language is sure, it's an artificial language that can be used for sorts of things, but it's really this. The rules are used for the interpretation of meaning of components in the structure. Basically, we want to have something that we can describe the way that everything works in a consistent manner. And we want to express that information in a consistent fashion itself too, right? So it doesn't help if I can get everything into CSV, but then I need another programming language in order to process that, or I need another system in order to actually do the whatever linking between those components there. So what I'm trying to get towards here is one system that we can use this. And the whole point, the only thing that you should be getting out of this really is to understand the meaning of this system, right? If you can model the entire system but gain no further insight into it, you have missed the point of modeling. So what my focus is here is some of the things that I've done, some of the crazy techniques that I've done for processing and actually understanding what a system means itself. And if you think about it, we literally make models all the time, right? How many times have you sat down on an application you're trying to understand, and you've literally sat there and drawn out all the routes, or you've generated data flows yourself, or you've made simple comments? This talk's whole point is to formalize these sorts of things. So you might see something in a code base that says this, right? This is actually very similar to another comment that I've seen before. Note, balance should be great, then withdrawal before execution, right? Now, it's just a comment. You have no idea what that actually means. There's all sorts of things there. We want to take those sorts of things and turn it into this. If you're old like me, you probably recognize this as JML. You maybe would notice that this would link into things like how Splint does its lightweight abstract interpretation. But basically, this is a set of invariants, a set of constraints, and a set of side effects that will occur within the application itself as we model things. So let's take this example, right? The original note was something very simple. Balance should be great, then withdrawal. So we have the misspelled withdrawal. Do we actually mean the withdrawal parameter? Do we mean the balance parameter? What do we actually mean here, right? And also, what does should? Like, what does should be mean? Does that mean it must? Does that mean the application will fail? Does that mean that we should require these sorts of things? What does this actually incur, right? And then at the end of this, what do we actually get out of all of this? So the note is trying to imply something. It's trying to add some very simple guidance as to what this function is doing or what this system is doing. But we're not really able to process this because we've sort of defined these sorts of things in a very fuzzy manner. We want to move away from that. We want to move to a system that enforces our spelling, right? We know that we're referencing this withdrawal versus that withdrawal, or this system parameter versus that one. We want to know that balance itself is modified. So we know that this function or this portion of the system will take a balance and will have a modification thereof at the end of it. We want to know something that like balance has to be greater than or equal to 100. We want to know that the withdrawal amount must be less than or equal to the total balance, etc. There are all sorts of rules that we're codifying here. And at the end, it's all enforced by our modeling language. And we ourselves no longer have to wonder about what we meant by when we scribbled a note that said balance should be great, then withdrawal before execution, right? And so the result is that we obviously have a better design, but now we also have a better understanding of the entire system. We can model this entire transaction flow because we have all these sorts of things here. And I know very frequently, if you look at this, if you deal with static analysis, if you're old like me and have dealt with JML, you probably have just seen this as like an invariant failure or a compiler failure or a refinement type failure, something there. But there's actually infinite output types that you can have from this. And if you take nothing away from this talk but this, it behooves you to start to look at what sorts of outputs you can get from what domain-specific languages you yourself can be writing or your team can be using. Obviously, this shouldn't be necessarily a private notation yourself, right? But you want to come up with something that your team and your workflows can actually work with. And there are really, the sky's the limits for these sorts of things, right? You can have process diagrams, all sorts of boxed visualizations, user process flows, any of these sorts of things. And you can then use those directly into your models themselves and start to understand where things break, understand the system itself, etc. Right? We need, and the other thing is too, when we talk about models, we very often have this view of like a model car. It's a sort of thing we build, we send it down a track, and then we're done. We need to stop thinking in that term as this dead thing. We built a model and now it's done. And we need to start thinking about simulation. We need to start thinking about how we actually access our models, how we process things, how we move through our system and attempt to actually understand what we're doing throughout, regardless, and start to actually struggle with the sorts of processes and constraints that we actually have codified into our system here. Now, I took the very simple model that we have, the very simple JML, and I generated a very simple process diagram, right? We know that there's some user that does this, that does a withdrawal amount. We have some withdrawal process, blah, blah, blah. We see the side effect is that we update user balance and we return a result of a new user balance. We might also have some sort of constraint diagram similar to what I'm showing here. So we accept the request if withdrawal is less than or equal to balance. We reject in red over here if the withdrawal is greater than balance, right? And then we know that what the withdrawal process is itself. These are the side effects thereof, that balance is less than the withdrawal amount and result is now balance is greater than or equal to 0. We have all of these sorts of things from a simple model that we're also using to enforce at a language level what invariants, what preconditions, etc. should exist within the program. Now, I wanted to take a very big example of modeling. This is from the Votes report. Votes is a public report, a threat model that Brian and I did, and it's quite large. There's a number of components that we had in place here. There's a number of things going on. You can see that it's multi-cloud. There's multiple security groups. There's multiple things here. But at the end of the day, we had to reverse engineer the same sorts of things ourselves during our assessment. One of the things that I'll be talking about here is lifting versus extraction and how we actually get these sorts of things into our systems. But this is the why. Brian and I sat down and we spent, Brian more so than me, especially on this portion, spent a ton of time trying to understand what data flow talked to which diagram, which component talked to which component within which diagram, etc., and so on, in order to actually get these sorts of things out. And we basically built a mental model to hand back to the client and say, does this look right? Does this make sense? What I'm trying to do and what I'd love for folks to do and what folks are working on is to move away from this sort of reactive approach where we build our models later and sort of into a new approach where we're coding and struggling with them much earlier in the process, despite the sort of beautiful work that we can do with these sorts of things here as well. So why do we model? So as a red team person, I'm going to be honest. I like threat modeling. I like risk modeling because it's the biggest bang for my buck. I can sit in a 1-hour meeting and I can get 10 to 20 findings out. I honestly can sit down and really start to process, ask a bunch of questions, and then sort of lazily sit back and report on these sorts of things, right? In terms of the actual level of effort, you can really cover quite a bit of ground with modeling itself there. And from a very simple call, you can have folks reconsidering designs. You can have folks realizing that there's a bug. You can have folks realizing that there's all sorts of issues just from talking it out. In a 30 to 60-minute call, all of a sudden you have all of these sorts of things fall out. You have different stakeholders talking, that sort of thing. But in reality, the other thing too is it simplifies down the system under test, right? We're sitting down and actually saying, distilling out, this is what I thought the system should be doing. And obviously it's a simplification. we know that there's a whole host of things that go into it. But for example, when you are working with an HTTP connection, you don't sit down necessarily and think about the socket connection that's under handling it, any of the processes in between, the packets necessarily at the wire level, because you're focusing on HTTP. Modeling is the same way. We're sitting down and we're thinking about our systems. We're attempting to find ways to abstract them, simplify them, and then find issues from there. So what do we actually model, right? I think in decreasing order of commonality, threat, maturity, semi-formal, and then we're really often missing anything but the first one, right? And when I say risk modeling, I actually do mean modeling, sitting down and trying to figure out what is the likelihood X the impact or whatever you do here. You get into all sorts of discussions of NIST 830, 37, 39, blah, blah, blah. There's all sorts of things that we do to form simple models as to the impact of the system itself, right? And then you can move to threat models. These are the potential for impact, right? So you can look up NIST definition, which I link in here. But basically, when Brian and I are wrestling with these sorts of threat models, we're really just asking, what can an actor do with this system? What controls do you have in place to uncover that had happened, or that you actually had stopped this to begin with, right? Threat modeling is all about talking through the potential things that could go horribly wrong. And then we get to maturity modeling. There's all sorts of things out here for maturity modeling. There's many different ones. The ones that I'm most familiar with are like Hunt Maturity Model, Prisma from NIST. There's a few things in there. But basically, this is an attempt to sort of qualitatively understand how robust, how strong, and often, for my case, how centralized your controls are within a system. And there's a whole posture versus maturity discussion that we can have later in this talk. But when we're maturity modeling, we're basically attempting to figure out and describe in some way how robust the controls and the security apparatus of this application or of the system under test actually are. Now, if you're in InfoSec, those all probably make sense. You've seen those sorts of things. Where I potentially go off the rails is with semi-formal modeling. There are all sorts of models, and you can do things like binary decision diagrams, excuse me. You can do, all sorts of like state machine diagrams here, etc. There's all sorts of areas. Or you can do lighter weight models, right? You can do some sort of symbolic execution. You can do some sort of interpretation from there. But basically, we want to talk about the mathematical and logical models of a system's flow, right? And we'll get into that, hopefully. We'll get into that sort of discussion there. And we'll talk through some of the processes that I've had and I've been thinking about to actually get to that place. So let's talk about the actual practical techniques, right? I think we need to move away from just the sort of dead models. And Brian makes amazing dead models. I make incredibly ugly dead models there. But that's not the end of it, right? It's not that we just need to stop drawing things. We also need to stop doing things like creating JML and then running it only once, right? Or we also need to just stop ending up with systems where we have an Excel sheet, we just capture a bunch of risks, a bunch of threats, they maybe go into a thing, and there's no actual impact. There's no feedback back into the system. And what I'd like us to do is move towards a system that we have these sort of like living models. We have code, we have data, we have all of those sorts of things that you can actually update, you can run against your system, and you can check how things are actually going and make sure that your current model, your current system actually matches what you have coded, what you have worked with. And I understand most people who work in InfoSec, who work in development, will probably laugh at this notion, right? We end up in a situation where we try to design all these things, we try to make things better, but they often just end up sort of relegated to the side here. I know that's possible. I know that's a very likely probability, but there are ways to at least increase this flow and make this a lot easier for everyone involved. And I think there are some folks who are doing really interesting work in this sort of space. Hillel Wayne, he works in TLA Plus. He has all sorts of articles on how to do formal modeling with TLA+. He also works with some other languages, I believe Agda as well. But he also has this really great blog post on just how to model adversaries. So taking a very simple system and then modeling what an adversary within the system can actually do, modeling how far into the system that we actually can, and actually processing what an attacker could do with access to the system there. We have Tamarin, which is a cryptographic proof system, and Tamarin allows you to actually show what happens when keys are compromised there. Someone I've worked with is Redshift Zero. She's on Twitter, Jen. She does quite a bit of work with automatic threat modeling in a continuous fashion, and she's put forward her blog post on how to do those sort of things. There's also PyTM, which is a great framework in Python, has some edge cases, and you can see what I've done with it in Kubernetes itself. But there's all sorts of interesting stuff there. To work in a modern fashion with threat models that aren't the sort of like dead systems that we've done in the past. But in all cases, you actually end up defining a model in some sort of code or in some sort of system there, and then you wrestle with the implications thereof. And then we have the ability to actually refine our models over time and apply them back to the system itself. So it's a super fascinating space. So can we do better, right? I think Tamarin has the right idea. Tamarin has some idealized crypto systems. It has some idealized algorithms, basically without the underlying side channel issues, maybe. But basically, you can place these within a system, and then you can do model checks within the system itself to see if you've misused keys or to see if you've misused like algorithms or those sorts of things. What I want to do is I want to start taking these sorts of ideas and applying them to InfoSec at large, right? I think there are many things that we can do with an idealized system, with an idealized data flow, that we can apply to a larger InfoSec practice in a domain-specific language itself. Obviously, your mileage may vary with these sorts of things, right? If you've done any modeling yourself, you know that there's no one-size-fits-all process here, right? So I really think that you maybe would need something with a lower level. Maybe you need something that is the same system, but maybe not idealized, right? You may have to struggle with these sorts of things. And obviously, you may have to refine how you work with these sorts of things. But having that abstract power there, having the ability to start with some sort of general primitives that you can start to wrestle with and codify your systems in, and then use those abstractions to build a larger program, build a larger system, is incredibly powerful. And we'll talk through some of these things. I also hope that you'll look through some of the links that I pointed you to. But there's quite a bit that we can already do without having to go out and codify all of these sorts of things and write our own DSLs. And I thought it would be fun to swag one. I thought it would be fun to take a stupid, wild-ass guess at what I would like to see there. Because why not? I think about this quite frequently. I'm always on assessments. I'm always wrestling with these sorts of things myself. And I really wanted to see what would it actually take to codify some of these sorts of things? What would it actually take to get into this space and wrestle with it? So I thought we'd start with the simplest one, right? Obviously, this is the one that most folks will deal with. This is the thing that we can see very frequently. And what I wanted to show is there's a very naive approach that we can take here. Let's just take something simple. We care about impact. We care about likelihood. We maybe care about severity. We maybe care about source and data. And we can define these very simple. We can have some sort of type that codifies data itself. We can have some sort of type that codifies component. And then we can just have a very simple structure that captures risk. And it has, a very simple integer for impact and likelihood. We maybe have some links out to components and other things there, data, etc. Very simple risk model itself, right? And for simple things, this is perfectly fine. We can easily define an API that works around these sorts of things. We can generate graph viz, right? We can have some sort of graph risk function here. It's fairly simple to work. We hand it an array of risks, and we end up with some sort of graph viz object. We can obviously report out of this itself, right? We can convert risks into a CSV. We can convert risks into an HTML table, all the sorts of things there, and then do the usual stacking and grouping and searching there. But I think there's something fundamentally missing from this model that we come up with. There's something very simple that we could do here that we're not, right? We're not codifying what impact actually is. It's a fairly manual process still here, and likelihood is as well. And it's completely disconnected from data, right? And we're not even codifying what impact is itself. Are we talking about like reputation? Are we talking about money? Are we talking about regulatory impact? What sort of impact are we actually talking with here? And this is something that I very often struggle with when we're codifying these things, when we're pulling up these models. Very often we start with something very simple and then we iterate very quickly into new DSLs or new models for these sorts of things. So there's a few different directions we can take, right? We could just add an API function that says calculate impact. It takes a reputational impact, confidentiality, etc. there, right? And that's fine. We give it a bunch of integers. We get an integer out. It does its thing. We don't necessarily know there. Now, what we could do is actually move away from that and make it a little bit more informationally dense, right? If you're given an integer, you don't actually know what the range of that integer is. There are ways of handling that with refinement types, but I haven't necessarily added them to Caramel yet. So a very simple way is to just actually use a variant type. We have some variant for very low. We have some we have some variant for going all the way up to very high. And we give it that there, and we actually move towards an actual dense impact calculation there. But can we do even better, right? Let's look at data itself. So there are a few different things that we could actually handle for data itself, right? We could start to codify the data subscription. We could start to codify if the data is regulated, those sorts of things. And then we can add that information density to the type of data that we're actually processing. And then when we calculate impact, we can give it impacted data. We can maybe give it an actor, those sorts of things, and then receive back an impact itself. Now, obviously, we can go even more dense here. We can return back an impact object. Impact could be a type that said reputation, impact, etc. But the point is to start to actually think about the sorts of data that you have and process it at a deeper level throughout your entire system and model it that way. So the obvious alternate direction, right, is to go to an uncontextualized risk. We have impact and likelihood. We have some source, etc. And then we then have a contextualized risk that processes and captures these sorts of things. We can move in either direction there. And I have talked way too long, but we can move in either direction there. But basically, we can do whatever we need to for our workflows. So if you take this away, it's to actually understand that your workflows are what matter here. Codify your DSLs and codify your introspection to actually match your workflows there, and allow yourself to tinker, right? Don't think that you have to come up with an idealized perfect model the first time that you work with it. Allow yourself the space to actually process these sorts of things and handle things later as you grow and as you improve your program. So if you take away anything from this, it's that there's many things that you can do. But really, you should experiment on your own information density, your own models, and process them as you need to. And make sure that they're ergonomic for your workflows and your programs as you need to process things and as you need to tinker with things themselves. So let's talk about threat modeling. I'll probably jump ahead in a second here. But let's talk about threat modeling really quick. We can capture potential impact to our system, and we can keep all of the things that we just defined for risk, right? We have enough for data, component, and impact itself, and we can reuse those to describe potential risks as well. So what I actually want to do is, what does this component talk to, right? When I go through in threat models, I am simply trying to capture who talks to what, where, how do we store it, how do we process it, and then actually have the outputs from these sorts of things be a consumable fashion. Those can be architectural decision records, they can be new architecture diagrams such as the one that Brian drew, etc. But we actually want to capture these in a single format that we can process there as well. So following down on how we process risks, we just have a simple uncontextualized threat here. We have maybe a system impact, an organizational impact. If you're familiar with threat modeling, you know what these are. But basically, we take all of the lessons learned from our previous model and throw them into this one here, right? And again, this is very simple for simple threats. If all we care about in our threat program is what is the impact to the system, what's the impact to the org, we can just use a very simple model like this, and that's it. Source, sync, and impacted data, we're absolutely done. Now, obviously, too, you can start to wrestle with this from the other direction as well. You can flip to mitigations. You can flip to remediation itself. And you can normalize all of this space here, right? You can process these things as you need to. But my recommendation is to start to work in ways that are very descriptive for you as well. And forget about normalization, forget about the sorts of processes that you have, and use the type system, use the class system, use whatever descriptors you possibly can to codify as much information at the logic level as you possibly can. All right, let's skip maturity for a second. Let's talk about semi-formal correctness. I think there's a very interesting space to be had here when in terms of semi-formal correctness, in terms of our models and the way that we work. And I know I'm butting up against time, but basically there are a few very different areas that you can work with. And if you are familiar with LangSec or you're familiar with some of the parser work that normally comes out, you may have already seen that as we build these definitional towers, we can actually build interpreters for these sorts of things. And there's an interesting paper that has just come out that's called From Definitional Interpreters to Symbolic Executors. But I think there's an interesting point here. Going back to Tamarin and going back to the simple systems that I spoke about earlier, I think there's a space to be made that we can start to interpret our primitives here from our risk models, from our maturity models, etc., and really start to define programs over the space of our InfoSec programs themselves. Obviously, a super spicy take itself. But I think there's also another direction that we can take, which is to have lightweight models that use things like design by contract and those sorts of tooling there as well, to actually process and handle things in a simpler method. And just before I bump up against time, the easiest one here is probably this, right? We have some sort of war game, we have some sort of risk that is contextualized, it has some additional information itself, we have some sort of component, and maybe we pass in a set of controls. And then we want to do a very simple match. Do we have a contextualized risk that is an SPII risk with an actor that is not restricted by any of the controls there? If yes, then we need to do all sorts of systems. Maybe we need to have an alerting process. Maybe we need to go through these sorts of things. But basically, we can codify from our models to a simple interpreter as to what things should be doing within our environments and how we process them further from there. Obviously, there's obviously quite a bit to unpack here, but when we have these sort of definitions, we can then start to simulate things ourselves in an interpreter fashion, in an executive fashion, and no longer do our war games and our tabletop exercises and those sorts of things actually need to be static processes that never live within our systems ourselves. We also can do symbolication of our components here, and obviously I'll hop off in a second, but there are all sorts of techniques that we can start to do as we go through and interpret our environments and as we go through and interpret our components to actually discover the constraints of even components that we haven't necessarily seen ourselves. And there's all sorts of techniques for those sorts of things that we can do. But in a nutshell, it's very similar to what I'm doing here. If you have a component, but we can't see that there's a load balancer in between, we simply add a symbolic one and start to collect constraints from there as well. So obviously, I'm taking a LangSec approach here. I'm looking at these sorts of things from a specification directive or this sort of space as well. Sorry, I'm looking at the chat as it goes. But there's a number of things that we can start to do. And if you think, yes, eventually, instead of programming in all the other languages, I program in my spec language, that is a risk that I'm willing to take. There's a number of things that we can do that we can extract to the common languages of our environment and process from there. All right, so I made it, I think. But are there any questions here? Anything that I can answer for folks? I know this is a very dense talk, especially since I talked so much in the beginning. But are there anything that I can clarify for people?
I think if we don't have any questions right now, what we can do is have folks post in the chat, or if you want, you can let everybody know your Twitter handle or anything like that. If they have any questions, they can follow up with you directly.
I'm logical everywhere.
Awesome. Thank you, Stefan.
Of course.
Greatly appreciate it. Seth, should I do the honors or should you?
I don't know. We can just all clap for Loji and then clap as Clinton comes in as well. 'Cause I'm excited to hear Clint. I always love